On today's episode, Ford makes a massive EV investment and a hypersonic missile breakthrough for the US military. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. Ford Motor Company has announced the company's biggest investment yet in electric vehicles. Ford CEO Jim Farley has announced an $11.4 billion investment in electric vehicle and EV battery technology, including a mega campus in Tennessee and 2 battery plants in Kentucky. 11,000 jobs will be created by the 2 projects. The Tennessee operation will be called Blue Oval City, built on a 6-square-mile site that will assemble next-generation electric F-Series light trucks as well as batteries. The large project will employ approximately 6,000 and will be both carbon neutral and zero waste to landfill. The campus will treat wastewater on site, and Ford hopes to eventually operate with zero net water draw from local sources. The campus will also include facilities for key Tier 1 suppliers who will be cloud connected to the Ford operations. The other project will be called the Blue Oval SK Battery Park, 2 battery plants built by a joint venture with Korean battery maker SK Innovation, which will build batteries for multiple Ford and Lincoln EV models. About 5,000 workers will be employed in the 1,500-acre Glendale, Kentucky operation, which will produce 86 gigawatt-hours of battery capacity annually. Scheduled to open in 2025, the location was chosen for easy delivery to Ford's North American assembly plants. Why so much investment so soon? The company expects that approximately half of Ford production will be all-electric by 2030. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. The race for higher speeds in aviation has been ongoing since the earliest days of wood and fabric biplanes. Development of jet engines and rockets has always been about speed, but for jet engine technology, hypersonic speeds, approximately Mach 5, have been difficult to achieve. Now, this flight regime operates beyond the capability of engines with rotating elements and uses an exotic variant of ramjet technology called scramjets, or supersonic combustion ramjets. The concept is to manage shock waves in the engine's intake and use them to compress that air, inject fuel, and ignite the mixture to produce thrust. There are multiple challenges, notably airframe heating, but in an important development, Raytheon and Northrop Grumman have announced the successful flight test of a scramjet-powered hypersonic air-breathing weapon concept, or HAWC, in a test for the Defense Advanced Research Projects Agency and the U.S. Air Force. The test article was carried under the wing of the mother aircraft, then launched with a solid-fuel rocket to bring it to supersonic speed, where the scramjet took over. Now, sustained hypersonic flight with air-breathing engines is a breakthrough, and for missile applications, hypersonic weapons are predicted to be a key enabling technology for new generations of lower-cost, long-range missiles. The Raytheon and Northrop Grumman program is aimed at delivering a prototype for the U.S. Department of Defense, with no single service announced as primary users of the technology at this stage of development. Other nations are actively working on the technology, notably China. The Beijing-based Institute of Mechanics has reported a testbed hypersonic engine capable of operating for 10 minutes, which is expected to be the basis for a new generation of Chinese military missiles. The relatively short runtimes of military hypersonic airframes makes hypersonics achievable with current technology, but the UK-based Reaction Engines company is developing advanced hybrid technology which, if successful, could deliver that holy grail of astronautics, single stage to orbit. Now, we're a long way from that achievement, but the Chinese and US military scramjet programs will likely feed valuable technology and material science into future civilian programs, exactly the way the commercial jet transport industry evolved. Faster is better. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future and Designing the Future, not found on our YouTube channel. The links are in the description below. Thanks for watching.